you that fast. And remember, the electrophoresis is not used in the criminal justice system. It's used in research. But I'm going to show you something right now that's used in research quite a bit. So first of all, the questions that you need to know here, which side of the gel is the positive gel? Which side is the negative electrode? Anybody remember? So we have DNA fragments that are negatively charged, isn't that right? And they're moving this direction, so therefore this must be the positive electrode down here, and this is the negative electrode. Agreed? All right. And again, this isn't really used, it's used in research still because it's inexpensive. And that's all I want to talk about in terms of gel electrophoresis. There is something called a blot, and that is you can take the gel, you can put it in this buffer, put a sponge here, put the gel here, put some paper here, put a weight and some paper towels, and the water will move from an area of high concentration to low concentration. When it does, it will actually carry the fragments off of the gel and stick them to a piece of paper. Then you can do more things with that piece of paper. I used to teach the classes all the different things that we could do with a piece of paper. I'll just tell you very quickly that we can do 3 types of blots. A western, a southern, and a northern. You should know that a southern blot is used to analyze DNA. A northern blot is used to analyze RNA. And a western blot is used to analyze proteins. So that was a series of test questions right there. Right? So you should know what a northern blot is, a southern blot, a western blot. And that there's no such thing as an eastern blot. Okay? So then, what are they doing these days? Well, I'll tell you what they're doing. If they're going to use the analysis of STRs, or short tandem repeats, or if they're going to analyze coding sequences in your DNA, they're going to do it with what's called DNA sequencing. And the way that you do DNA sequencing, this slide, don't worry about it, it's the old way. Nobody does it this way anymore. This is the new way. This is the way they do it. It's called the Applied Biosystems 300, and the way it works is that when you put a specific sample into the machine and you let the machine run for a period of time, you will get an electropherogram just like this. And if you look very, very closely, you'll actually see the nucleotides. So the computer is actually telling you the nucleotides that are found on the sample that you put in there. So when the computer knows that the short tandem repeats are 12 from your mom and 14 from your dad, it's because the computer is actually seeing these nucleotides and counting them up, counting up those short tandem repeats. So this DNA sequencing, to me, this is just an opinion, is literally 1,000 times more accurate than using a blot. Because just using fragments that travel through a gel based on their size, okay, that's one technology, but this is exacting technology. This is perfect technology. Sometimes the ends don't come out so well, that's what this means. But then when you see these really sharp peaks, that means the computer literally has a 99, 99.8, 99.9% accuracy with these sharp peaks, but some of these have to be ignored. So a lot of times you'll just take several fragments and have them overlap, or do it again until this region comes up in the center, and then you can really get accuracy here. So this is DNA sequencing. This is exactly the way they do stuff now. Applied Biosystems, I told you, was even willing for a price to sequence all of your DNA. The chromosomes you got from your mom and from your dad, give them to you in a book, and put them in on a DVD or a CD containing a series of files. And then that way, when the news comes out that they found a genetic marker for a certain type of cancer, you could literally search your DNA to see if you have that marker for that cancer or for that disease. So this is, again, I believe she did a pretty good job of telling you what short tandem repeats are. For instance, here are 7 of them, 1, 2, 3, 4, 5, 6, 7 that have come from one parent, 8 that have come from another parent. This is just the analysis of one location. And again, how many locations do they analyze? 15. And by the way, it's the probability of one times the probability of the next, times the probability of the next, times the probability of the next. That's where you get these astronomical numbers. I think this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I said, I want to get a picture of you and the rhino. And then she held up her middle fingers and said, no. I said, yes, I want to get a picture of you and the rhino. She said, okay. So the rhino's laying down, he's sleeping, and I'm getting a picture, and she says, okay, hurry up, take the goddamn picture. And she says, how will I know? You'll let me know when the rhino gets up, right? And I said, and I'm waiting there because I'm trying to get the rhino to stand up, because that would be even a better picture. But the truth of the matter is that rhinos have very, very poor eyesight. And I've had rhinos chase us around a little bit. And they run past you, and then because the eyes are on the side of their head. So while they're running, and sure, you see the horn coming at you, there's no eyes. So you just have to stand near a bush, near a tree, next to a car, and they run right past you, and then they stop, and they have to look at you, and they have horrible eyesight, so they walk up, and they're not really... She's a lot more dangerous.
What's in the background? That's not a hotel, I think.
No, it's just a building. It's just a building. You're just walking around. All right. So next we're going to do 11, correct? And I should have finished 11 last time, isn't that right? I'm a little behind. All right.
Aren't we still ahead?
So. All right.
No, we're behind. We're supposed to be on chapter 12.
I will get you caught up. Guarantee it. Ready? Starting about here is where the course really starts getting good. I'll be honest with you. Up until now, a lot of it's review, right? A lot of it's biology, right? So now let's start teaching you some of the things that you'll only learn in a micro class. So 11 and 12 are separate because chapter 11 are all of the ways that we can destroy microbes outside the body. Chapter 12 are all the ways that we can destroy microbes in the body. Let's give you just a quick example. What's the difference between an antiseptic and a, let's see, if I even have this. It's a buffer.